Hello friends, in this video we are going to study the pin diagram of 8087 math coprocessor. This coprocessor is paired with the 8086 and 8088 microprocessor family, and here we are going to study its pin diagram. Then we will study the function of each of the pins of the 8087 coprocessor. So let us start with our topic. The 8087 coprocessor, it is the first coprocessor developed by the Intel to pair with the 8086 and 8088 microprocessors. The function or the use of this coprocessor is to speed up the calculations, because the complex arithmetic and trigonometric calculations cannot be performed by the 8086 and 8088 microprocessor. Also, if we are dealing with very large numbers and very small numbers, then also the calculation based on them cannot be done by these microprocessors. So to speed up the calculations and to perform these complex arithmetic calculations, coprocessor is developed, and each microprocessor in the family of 8086 and 8088, each microprocessor is having its own coprocessor. So 8087 coprocessor was the first coprocessor which is paired with the 8086 and 8088 microprocessor. This 8087 coprocessor, it is also known as the floating point unit and the numeric data extension. So there are some other names also for this. It is also known as the math coprocessor because mathematical calculations are done by it. Also, it is known as floating point unit. And it is also known as numeric processor extension. So depending upon the functions performed by it, there are some other names also for this 8087 coprocessor. So it is used to speed up the calculations so that the microprocessor is free from these tasks, its CPU is free, and it can perform some other important functions. Okay, so 8087 it is used for easy and faster calculations. So here we will study its pin diagram of 8087. So let us first take a look at its pin diagram. It is a 40 pin IC, so there are 40 pins on the chip of the 8087. So this is the pin diagram of the 8087 math coprocessor. You can see that it is having 40 pins. 20 pins are on the left hand side and 20 pins are there on the right hand side. Numbering is from 1 to 20 and then 21 to 40. Okay. Now here pin number 1 is VSS and pin number 20 is ground. This is pin number 40, which is VCC. So these three pins are for the power supply connections. VSS and ground, they are one and the same thing, that is ground is connected with it, and VCC, it is the power supply. Okay, that is plus 5 volts of power supply is connected here. So now we are having the, because this 8087, it is having 16 data lines and 20 address lines. So 16 data lines, that is from D0 to D15, and 20 address lines, that is A0 to A19. Now out of these 20 address lines, the 16 address lines, they are multiplexed with the data lines. So we are having AD0 to AD15. These are the multiplexed address data lines. So here you can see AD14, AD15 is here, 14, 13, 12 till AD0. So AD0 to AD15, we are having 16 address and data lines, and after that we are left with A16 to A19. These are A16, A17, A18 and A19, the 4 remaining address lines. So total we are having 20 address lines and 16 data lines, but 16 data lines and 16 address lines, they are multiplexed with each other, means they can be used as the address lines also and as the data line also. Okay. After that, pin number 17 and 18, they are not connected. So NC and NC, that is not connected, is written here. Then 19 is the clock pin, that is clock signals are given through this pin. Pin number 20 is ground. Pin number 21, reset, ready, busy. We will study these signals in detail afterwards. Then QS1, QS0, these are the Q status lines. Then S0, S1, S2, these are status lines. Then NC means pin number 29 and pin number 30, they are again not connected. They are left for the future use, means if any future expansion is done, then these pins can be used. After that, we are having RQ naught and GT naught, that is the request and the grant signal. This is the first request and grant signal. This is the second, that is RQ1 and GT1. So there are two request and grant signals pin. Then INT for interrupt. Then BHE, that is bus high enable, which is this pin is having dual use, means it can be used as BHE signal also and as S7 status line also. So its use is dual. Again, we are having pin number 35 to pin number 38. They are also having dual functions. They can be used as the address lines also and as the status lines S3, S4, S5, S6 also. So these pins are having dual functions. They can be used as address lines also and status lines also. After that, we are having AD15, again the address and the data bus multiplexed line, and this is VCC, that is the power supply connection. So this is just a quick overview of the pin diagram of the 8087 coprocessor. Now we will study it in detail, that what is the functions of these pins and how they are used by the processor. First, we will start with the address and the data lines. We saw that we were having AD0 to AD15. The 16 address lines which are multiplexed with the data lines. So these are the time multiplex address data lines. Okay, so they can be used to carry the address of the register or the memory, or they can be used to carry the data also. In the first clock cycle, they carry the address, and in the second clock cycle, they carry data. Okay, so it is having dual use. It can carry address also, it can carry data also. In first clock cycle means that when the instructions they are executed by the processor, then the instructions are executed in different stages, so different cycles are there. So each instruction execution is divided into several clock cycles. So in the first clock cycle, these lines are carrying the address. In the second clock cycle, these lines are carrying the data. So dual functions are there for the. So these were only the 16 lines. Remaining were the A19 to A16. We have seen in the pin diagram that A19 to A16, they are having dual functions. These pins are having dual function. These pins, that is 35 to 38, they can be used as these A19 to A16 address lines, and also they can be used as S6 to S, S6 to S3 status lines. So initially they will be carrying the address, and afterwards they will carry the status. Now just like the status lines of the 8086 microprocessor, these lines are also used. Means initially the S6, S4 and S3, they are high, whereas S5 it is low. So permanently the S6, S4 and S3 status lines, they are high, whereas the S5 status line, it is permanently low. Okay, so these are the A19 to A16 lines, that is pin number 35 to 38. After that, in the pin diagram, you can see we are having the BHE and S7 line. Okay, that is pin number 34. So this pin is also having dual function, bus high enable, BHE and S7. BHE is an active low signal. Now during the first clock cycle, this signal or this pin is used to enable the data on the data in the address lines, and afterwards it will work as the seventh status line. So during the first clock cycle, if this BHE signal it is low, means because this is active when its value is low, that is 0. So in the first clock cycle, if this signal is active, so at that time data will be present on the higher byte of the data address lines. Means that the A0 to A15. Okay, on this data is available. because we have seen that it is multiplexed with the data line. So AD0 to A15, on those lines data is available if this signal is active. Now afterwards it will work as the status line S7, which is used during the T2, T3 and the wait T state and the fourth T state. In the first T state it will work as the bus high enable, and afterwards it will work as the status line S7. Next we are having the QS1 and QS0, which are the Q status lines. These are two lines, so it can have four combinations: 0 0, 0 1, 1 0 and 1 1. As they are known as the queue status lines, so they provide us the status about the instruction queue of the processor. Instruction queue means that whenever the microprocessor or the processor they executes the instruction, first they fetch 6 instructions at a time. Now these 6 instructions they form a queue which is called the instruction queue. So whether this instruction queue is empty, whether it is filled, or which operand we have to fetch. Okay, so to get the status of that instruction queue, we are having these two status lines. Okay, let's see that what is the value of this. 0 0 means no operation. 0 1 means first byte of opcode from the queue. Means the microprocessor has to fetch the first byte of the opcode from the queue if these status lines are 0 1. Afterwards it is 1 0 means empty the queue. Microprocessor will empty the queue is empty. Now it will start again fetching the instructions. 1 1 means subsequent byte from the queue. So this is how the microprocessor will get to know that what is the status of the instruction queue. If these lines are 0 0, no operation will be there. 0 1 means first byte of the opcode will be fetched from the queue. Then 1 0 means the queue is empty. 1 1 means subsequent byte is being fetched from the queue. So here you can see in the pin diagram that we were having QS0 and QS1, the Q status lines. After that, we are having the INT here, 32 number pin. INT is the interrupt pin. So INT is an interrupt signal. This signal changes to high means this pin becomes high when an unmasked exception has been received during the execution of the data. Okay, means when the processor is doing some numeric data execution, at that time if any unmasked exception or an interrupt has occurred, then this interrupt signal will go high. Okay, so this was INT. After that, we are having a pin named as busy. When this pin is high, it means that the 8087 coprocessor, it is busy in doing some task, so that the microprocessor 8086 and 8088 they will get to know that 8087 is busy, coprocessor is busy in doing something. Okay, Next is the ready. You can see these pins in the pin diagram. INT is here, then busy, ready and reset. Pin number 23, 22 and 21. Ready, it is an input signal which is used to tell the peripheral devices that coprocessor it is ready for the communication. Okay, because there are sometimes, because we know that 8087 it is very fast in its calculation, its speed is very fast. So if there are some input output devices also known as the peripherals which are very slow in their operation, so if such slow peripherals they want to communicate with the 8087, then first they will see that is 8087 is ready for the communication or not. Okay, so that they can cope up with the speed of the processor. So ready signal is used to indicate those slow peripherals that 8087 is ready for the data transfer or for the data communication. So it is used to indicate the 8087 that the bus is ready for the data transfer or not. Okay, when this signal is high, it means that it is ready. After that, we were having pin number 21, that is reset. Reset pin is used to reset the processor, to bring all its internal activities, to stop all the activities and to bring the processor to its initial state. Okay. So this signal is used to reject the internal activities of the coprocessor. Reject means to stop all the internal activities, all the calculations it was doing, every task will be stopped and then it will be prepared for further execution whenever required by the CPU. Okay, so whenever CPU will require that 8087 starts its processing again, so this signal will be made low. When it is high, then all processing will be stopped. So this is the reset signal. After that, we are having the ground at pin number 120 and 40 is the VCC, that is the power supply. Okay, I have already told you. After that, we are having at pin number 19, that is CLK, which is the clock signal. So this clock pin, this pin number 19, it provides the basic clock signals or timings to the processor. Okay, means if any synchronization with the clock has to be done, any timing and control signals which are synchronized with the clock signals, any clock input is to be provided, that will be done by this pin number 19. Then VCC, which was the plus 5 volt power supply, and VSS or ground for the ground connection. So these are the power supply connections. After that, we were having the status lines, okay, that is S0, S1 and S2. Okay, so pin number 26, 27, 28, these are the status pins. S0, S1 and S2. Status signals. These status signals provide us the status about the operations of the microprocessor. That means that whether the processor is performing, what type of operation the processor is performing, like whether it's memory read, memory write, input output read, input output write, what type of operation the processor is currently performing, that will be indicated by these status signals. So we are having different combinations of it: S2, S1, S0. Okay, then so it indicates when its value is 0, they can be 1 or 0, that is 011 or 010, 001, 010. They can be anything. If the S2 line is 0, then it is unused. When it is 100, then also it is unused. When it's 101, then it's a memory read operation. If it is 110, then it is memory write operation. If it is 111, means it's a passive operation. So it indicates the status of the operation which is used by the bus controller 8087 to generate the memory and the read and write signals. Like if memory signals are to be generated in the 101 and 110 status, read signal is to be generated in this position, write signal is to be generated. So what type of signals are to be generated by the processor and what type of operation is to be performed, that will be indicated by the status signals. Okay, now after that we are left with the request and the grant signals. We can see here there are two pins for them, RQ0 and GT0, that is request and grant signal 0 and request and grant signal first. So we are having RQ0, GT0 and RQ1, GT1. These are the request and the grant signals. Because the processor 8087, it is using the same bus and the same clock signals and input output system of the microprocessor. So it, whenever it wants the use of those buses or those input output system, it has to give a request to the microprocessor that I want the control of your buses, and in response to them the microprocessor is going to generate the grant signal that it has given the permission to the 8087 that it can use its buses. So request signal is generated by the 8087 and grant signal is given to 8087 by the microprocessor. So these signals are used by 8087 to gain control of the bus from the host processor 8086 or 8088 for the operand transfers. So this is the complete explanation of all the pins of the 8087. We saw that we were having 40 pins, and though out of those pins, 4 pins are not connected. Okay, and rest of the pins, each pin is giving some function or some signal is associated with it. And we have seen the function of all these pins, the function associated with them, that some of them are used as the address and data lines, some of them are used as the status lines, as the queue status lines, and interrupt, busy, ready, reset. Some are used as the power supply signals, clock signal is there. So we studied the function of all of the pins, all of the 40 pins of the 8087 math coprocessor. Okay, so I hope that this topic is now clear to you. Thank you.